Hello, good day and welcome to my channel. If you look at the problem here, you see a system of forces, and this tells us that we are under the branch of applied mathematics. So this problem is under applied mathematics. Now the question says that from the system of masses shown, find A, the acceleration A of the masses, and B, the tension T in the rope. And I should take the acceleration due to gravity G as 9.8 meter per second square. So now let's look at the solution. If you look at this diagram, you see these two masses hanging over a smooth pulley. We are taking this pulley to be one without friction. So a smooth pulley, and then we have the 4 kilogram mass and the 3 kilogram mass. You will agree with me that this mass will definitely go downward. That is, the 4 kilogram mass will go downward, pulling the 3 kilogram mass upward. Now, looking at this, we have a rope here, and this rope normally is to pull this upward. So the weight of this 4 kilogram mass will act downward as mg. That is the weight. It will act downward as mg. So mg means the mass multiplied by acceleration due to gravity. So if we multiply this 4 by 9.8, it is going to give us 39.2. So we have 39.2 Newton as the weight of this 4 kilogram mass. So the weight will act downward. And then the rope, which normally is to pull this upward. Don't forget, a rope is used to pull an object. So this rope tends to want to pull this mass upward in the opposite direction, and that means the tension should act in that direction, T. So the tension acts upward. Then looking at this as well, the mass downward here, that's the weight of this downward, should be mg. And then 3 multiplied by g, which is the acceleration due to gravity, 3 multiplied by 9.8 will give us 29.4 as the weight of this, 29.4 Newton. So that is the weight of this 3 kilogram mass. And then the rope here tends to pull this mass upward. So in that case, the tension will also go in this direction as T. The same tension, since it is the same rope over the pulley. So we have the tension that tends to pull this upward, and the weight that tends to pull it downward in both cases. So the tension in this direction, the weight in this direction. Now looking at the 4 kilogram mass. Looking at the 4 kilogram mass, we know that it will go downward. This mass will go downward. So its weight, which is 39.2 Newton, should be greater than the tensional force, T. And so resolving now, the resultant force will be given as that particular weight. But don't forget that from Newton's second law, we have F is equal to ma. Let's put that down first. From Newton's second law, F is equal to ma. So if we look at this 4 kilogram mass, the weight, which is 39.2, as I have it, let me put it 39.2. Then minus the tension. Don't forget the weight at this upward with this 4 kilogram mass will definitely move downward. And it is greater than the tension which is going upward. So this downward force is 39.2, and then minus the tension upward, which is T, that should be equal to ma from this formula F equals to ma. So this 39.2 minus T is the resultant force with which this goes down. And that resultant force with which it goes down will be equal to MA, which is written as M is 4 for the 4 kilogram mass, and then A is the acceleration. So don't forget, 39.2 minus T is the resultant force downward, and that will be equal to the mass times acceleration of the object. So this is the first part. So we can simplify this further now. We can simplify this further by rearranging. We can simplify further by rearranging. For us to rearrange, we can simply write this negative T first. And so write as negative T. And then this 4A comes to this side. It becomes negative 4A. Negative 4A. And that will be equal to 39.2 coming to the right hand side becomes negative 39.2. So don't forget that. Then now when we move to the other object, now we are through the 4 kilogram mass. Let's come to the 3 kilogram mass. Now the force with which it goes down, which is the weight downward, is 29.4. That is the weight downward, 29.4. The tension upward now, which is T, is definitely greater than the weight downward because this 3 kilogram mass will move upward. So it means that the pulling force upward, which is the tension, is greater than the downward force, 29.4. So that means the tension T, which is greater, should be written first, then minus the downward force, which is lower, 29.4, should be equal to the mass times the acceleration. So this T minus 29.4 is the resultant force with which this moves upward. And that will be equal to the mass times acceleration. The mass for the 3 kilogram is 3 and the acceleration is A. So if we rearrange this now, we have T, and then this 3A comes to this side, becomes negative 3A, and that will be equal to negative 29.4 comes to this side, it becomes positive 29.4. So don't forget, we are dealing with the part A of the question. So now the next thing to do is to solve these two equations simultaneously. We're going to solve these two equations simultaneously. So if you check the T part now, they are of the same coefficient but with different sign, negative 1T and positive 1T. So for us to eliminate T is easy. We just simply add them. So once we add these two parts now, T will be eliminated. So negative T plus T will give us 0. 0T, which is 0. So T has been eliminated. Then now moving to this side, let me rule a line there. Moving to this side, we have negative 4A added to negative 3A will give us negative 7A. And that will be equal to negative 39.2 added to positive 29.4 will give us negative 9.8. Negative 9.8. So in order for us to get the value of A, we simply divide both sides by negative 7. So if I divide both sides by negative 7, I'll be left with A is equal to negative 9.8 divided by negative 7. The negative sign will cancel negative sign and we are left with 9.8. If we divide this 9.8 by 7, it will finally give us A is equal to 1.4. So A is equal to 1.4 meter per second square. So this is the acceleration of the objects as they move together. So that is the final answer to part A. Now let's look at how part B is carried out. So let me write B here so that I can go along and solve it. So B, now for us to solve B, we already know the value of A. So getting the tension now should be easy because the question B is asking us to find the tension. You can see it here, the tension T in the rope. So for us to find the tension, what we need to do now is to take one of the two equations that we have there. If you look at these two equations, now we can take any one of them and use it to find the value of T. So let's take this second equation. That is T minus 3A. T minus 3A is equal to 29.4. So in place of A, let's substitute 1.4 since we already know the value of A as 1.4. So I'm going to say T minus 3 multiplied by 1.4, and that will be equal to 29.4. So T minus 3 multiplied by 1.4 will give us 4.2. So I have 4.2 is equal to 29.4. Moving on, we have T is equal to the 29.4 now. When this negative 4.2 comes to this side, it becomes positive 4.2. And then finally, I can have T is equal to 29.4 added to 4.2 should be equal to 33.6. 33.6 Newton. Don't forget, tension is a force. So Newton. So that gives us the final answer. So please don't forget to subscribe to this channel. You can comment and ask any question that you have, and then share this video so that others can see it. Please subscribe, and then I'll see you in the next video. Don't forget, subscribing to this channel will make you get more interesting and educative videos like this. Thank you for watching, and see you in the next video.